Today, citizens in first-wave countries and increasingly second-wave countries spend ever smaller proportions of their income on food and can almost always expect to have a broad selection of food available for purchase in shops, cafes, and restaurants, or even delivered to their homes. Food production, distribution, and storage are obviously an essential part of humanity's ability to not only survive, but thrive. In this third video, we will see how we can expect total food consumption to double or triple, and specific foods may even increase 10 times over the remainder of this century as the world's population continues with its transition from an agrarian to an urban industrialized society. As always, we will take a broad historical perspective. We will look at how food production and consumption has changed over the past 300 years, how we have been able to meet rising demand for food, and what is required to continue to meet this demand. We will describe the so-called total productivity factors, or total factors of productivity, which are crucial for increasing the volume of food we produce. We will examine how these factors worked for the last 300 years and how they might work in the future. Finally, we will examine how environmental considerations further complicate an already challenging situation. What will be patently clear is that in the next several decades, we need to reinvent agriculture. As we covered in previous videos, the dominant megatrend behind the last 300 years is the great transition from an agrarian era to an urban industrialized society. This process started in the 18th century in Western Europe. We have seen how countries go through a demographic transition. Now, let's cover another aspect of the Great Transition: the dietary transition. When first-wave countries began their Great Transition 200 to 250 years ago, they saw significant improvements in their diet. In a typical agrarian society, we see around 300 to 400 kilograms of food per year per capita. This diet is mostly comprised of cereals, pulses, and roots. As these first-wave countries transitioned, diets improved significantly, and today, on average, they consume 3 times more food, or around 900 kilograms of food per year per capita. Their diets continue to contain cereals, pulses, and roots, but now in smaller quantities than before. In general, it falls to around 200 kilograms of those products. However, these countries see significant increases in their consumption of meat and dairy. If the typical person in an agrarian society in the 18th century consumed around 15 kilograms of meat, vegetables, fish, and dairy, then a person in an urban industrialized society consumes around 90 kilograms of meat alone. In fact, in some first-wave countries, such as the U.S., meat consumption is closer to 120 kilograms per capita per year. If we look at this from a calories per person per day perspective, this dietary transition sees people move from 1,500 kilocalories per capita per day to 3,000 kilocalories, and doing so from a more varied diet. In an agrarian society, 90% of food intake is carbohydrates and 10% fats and proteins. In an urban industrialized society, it is 60% carbohydrates and 40% fats and protein. This represents huge progress for these countries who complete such a dietary transition. More varied diets allow for healthier citizens. More calories allow for more activity, including intellectual activity. And even more basically, these societies do not experience famine. However, we should not forget that the growing per capita food demand is rising at the same time the population is rising. First-wave countries' food consumption did not simply triple, it increased by 10 times or more, as its population also tripled. Yet, the Great Transition is not limited to first-wave countries. It is simply that first-wave countries were the first to begin the transition. From the middle of the 20th century, the second-wave countries started their Great Transition, and along with it, their dietary transition. When the most populous second-wave country, China, started its dietary transition, its citizens consumed only 4 kilograms of meat per capita per year. 60 years later, they consume 60 kilograms per capita per year. When we consider that China's population in 1950 was around 550 million and today it is almost 3 times the size, we see again that China's food demand increased by around 10 times. And yet, at 60 kilograms of meat, it is still below first wave levels. In fact, it is half of U.S. levels. So we can expect its demand to continue to grow as it completes the transition. The second wave countries, and now third wave and even fourth wave countries, are following the same path that the first wave took. We can see that in those countries who have yet to complete their great transition to an urban industrialized society, current levels of food demand and consumption are far lower than in first wave countries. This allows us to confidently predict that the demand for food will grow rapidly this century, anywhere between double and triple today's levels. The Food and Agriculture Organization of the United Nations projections for 2050 suggests that since income levels will be many multiples of what they are now, in order to feed this larger, more urban and richer population, food production must increase by 70%. This is just by 2050, and it will need to rise far higher still by 2100. It is hard to be precise, but annual meat production alone would need to grow from 300 million tons today to between 600 and 900 million tons by the end of the century. Most FAO projections do not go to 2100, and there are cultural differences in the kind of food consumed. Culture here plays a larger role in other aspects of the Great Transition. For example, there are first wave and second wave countries that consume far lower levels of red meat than most of their counterparts. Countries such as Japan and Indonesia. Seafood plays a far larger role in their diet. Other regions, such as the Middle East and South America, consume far more meat than their counterparts. China consumes only 20 kilograms of dairy per capita per year, below even the level of many countries' agrarian-era consumption levels. It is not clear if Chinese consumers will start consuming more dairy in the future. China now consumes 400 kilograms of vegetables as compared to first-wave countries who consume about 100 kilograms per capita per year, and fourth-wave countries who consume between 20 and 80 kilograms of vegetables per capita per year. Nevertheless, all countries will experience major growth in demand for food as incomes increase. What the 4Waves approach focuses on is growing demand and society's push for a better life, at least doubling the calorie intake during the dietary transition at the same time as varying the diet. So we can be sure to expect food demand to grow long beyond 2050. But can the world increase its food production at this rate? In some ways, history paints a very positive picture. The progress that first-wave countries made was so significant that in the middle of the 20th century, the 1 billion people living in first-wave countries produced half of the world's food. In 1961, when the Food and Agriculture Organization statistics started for all countries, Australia produced the same amount of meat as the whole of Africa. Yet in those 60 years, Africa has increased its production from 1 million tons a year to 50 million tons. Globally, we have gone from around 7 billion heads of livestock to 30 billion. Beef production has more than doubled, while over the same time, chicken meat production has increased by a factor of nearly 10, made up of increases in both number of animals and productivity. Concerns raised in the 18th century that the world would not be able to feed the demographic boom today appear to have been disproved. The dietary transition has been made possible as a result of increasing the amount of land available for agriculture and by increasing yields through fertilizers, mechanization, and other technologies. During the past 300 years, we have seen an increase in the amount of land available for food production. From the prairies of North America to the expansion of agriculture in Australia and Central Asia, vast new areas of land were brought into production. More prominently, vast areas of forest were cut down to be turned into grazing pastures. In the 19th century, we doubled available land to 2.5 billion hectares. We then doubled available land again in the 20th century to 5 billion hectares. But we are now at the limits of our planet's total available land. We have potentially the option to increase available agricultural land by 5 to 10%. The total amount of the Earth's surface covered in land covers around 150 million square kilometers, or around 15 billion hectares. 300 years ago, around 60 million square kilometers, or around a third, was covered in forest. 10 million square kilometers were used for agriculture. Today, we use 50 million square kilometers of dry land for agriculture and have a third less forest, or 40 million square kilometers of forest. All further expansion of agricultural land comes at the expense of forest. Brazil has increased its land use for agriculture over 4 times over the last 100 years and still uses only 40% of the potential agricultural lands. But we know that these lands come from the Amazon rainforests. Farming competes directly with forests. Of the current 50 million square kilometers of agricultural land today, 80% is used for livestock. Of course, this includes dairy production and not just meat. If we look at increasing yields, increased GDP allowed more capital to be poured into increasing agricultural yields. Following the Second World War, industrialized production of nitrogen fertilizer allowed for rapid increases in agricultural output in second-wave countries. The Green Revolution, using a mixture of these fertilizers, crop selection, and increased use of machinery, such as tractors, saw many forms of agricultural output doubling. This required significant increases in energy input to produce crops, increases proportionately far higher than the increases in output. Agricultural machinery and chemical fertilizers both rely on or are derived from crude oil, making agriculture increasingly reliant on crude oil extraction. Machinery needs to be manufactured. The need to increase food production does not take place in a vacuum. Energy production also needs to increase, and as we will see the impact of this in later videos. These productivity increases come at an environmental cost. In the early 20th century, we used around 10 million tons of fertilizers, but we now use 100 million tons of nitrogen fertilizers and about 50 million tons of phosphorus fertilizers. This heavy use of fertilizers creates multiple problems. One problem is the nitrification of soil and water, also known as dead water. Fertilizers get into rivers, seas, and oceans. This creates vast areas of plankton on the surface, which prevent the sunlight from reaching life below the surface and preventing the ability of fish and other creatures to survive in those areas of the ocean. Nitrous oxide is also emitted as a result of nitrogen fertilizer use, which is an aggressive greenhouse gas. These are but 2 of many issues with overuse of fertilizers. Despite the possibility of improvements in first-wave countries to decrease fertilizer use, third- and fourth-wave countries have a long way to go to catch up to their levels. This means we can expect significant increases in fertilizer use over the coming decades. Moreover, food production's impact on climate change is not limited to nitrogen fertilizers. The food production industry is responsible for around a quarter of global greenhouse gas emissions. 1.5 billion cattle for meat and dairy production alone has the same emissions as the global transport sector, including its roughly 1.5 billion passenger cars. Moreover, climate change also influences production. We need the number of cattle to increase 2 or 3 times, and we also expect the number of cars to more than triple. There are many efforts to generate new technologies to increase food production and productivity. These include efforts from artificial milk and meat to vertical farming. However, the question is, how long will it take for these technologies to significantly relieve the pressure on our environment and meet growing demand? With demand for food set to double or triple this century, these technologies will need to provide historically unprecedented scale and acceptance in a very short space of time to prevent environmental catastrophe.